Hello, Precalculus class. How are you guys doing? All right, today we're going to continue on. Uh, we have pretty much finished talking about counting now. So we talked about the multiplication rule, we talked about how to count permutations and combinations and those type of things. So we're pretty much done with doing those counting problems, but we are going to have to use counting when we are doing what we are going to start today, which is probability. All right, today we're going to start talking about probability. Now, in your notebook, the last thing we did was these counting things. The next thing in your notebook is a section about using the binomial theorem. We're not going to mess with the binomial theorem. We're going to go ahead and skip over it. So you can skip a couple of pages in your notebook and you will come across this page. Where is it? Ta-da! Where it says Introduction to Probability. All right. Now, probability, we will be using the counting techniques that we have already learned. So make sure you don't forget those. We still need to know how to do them. But we're going to begin by going over some words, some ideas. So it says a probability experiment is an action or trial that has varying results. That means every time we do this action, different things could happen, and we do not know what will happen. So an example of a probability experiment would be rolling a die, all right? If you roll a die, there are many things that could happen. You could get a 1, a 2, a 3, a 4, a 5, or a 6, all right? And we don't know which one is going to happen before we roll the die. So that is called a probability experiment. Another example of a probability experiment would be if I had every student in our pre-calculus class write their name down on a piece of paper, on a little tiny piece of paper, and I put it into a bag or a box or something, and I closed my eyes and I did this, and I pulled out one. Well, again, that would be a probability experiment or a probability action, because when I do this action, there are many different results, varying results. I could get Benson or Michael. I could get Emily or Gina. There's many different possible results, all right, that could happen. And I don't know what is going to happen before I do it, before I see it, all right? So those are called probability experiments. They are just things that we do that could have many different results, and we don't know what the result is going to be, all right? So let's talk about some more words. All right. The possible results of a probability experiment are called outcomes. All right. We call them outcomes. OUTCOMES. All right. All right. So, for example, let's go back to rolling a die. All right. An outcome would be 1. 1 is an outcome, or 6. 6 is an outcome, all right? Anytime I roll my die, 4, that's an outcome, all right? So it says here, for instance, if you roll a 6-sided die, the possible outcomes are, what are all of the possible outcomes? Well, this is going to be a set, a group of numbers, so I'm going to draw brackets here, all right? Brackets, and what are all the possible outcomes? Well, you could get a 1, you could get a 2, you could get a 3, a 4, a 5, or a 6, right? Those are all the possible outcomes on a 6-sided die. You can't get anything else. You can't roll a 7, a 0, or anything else. These are all the possible outcomes, all right? Now, a collection of one or more outcomes is an outcome set. All right, we're going to call it an outcome set. All right, an outcome set. So if we group a bunch of different possible outcomes together, that would be called an outcome set. And they give an example as rolling an odd number. Okay, rolling an odd number would be an outcome set. It would look like this: 1 or 3 or 5. Those are the different outcomes that are odd numbers. All right, so this is an outcome set. All right. And I'm sorry. I am in class right now. Bye. Ha ha ha. All right. I don't have any way of pausing this video right now. So, all right. The set of all possible outcomes is called a what? All right. What is the set of all possible outcomes? It's called a sample space. All right. Sample space. And usually, we will often write the sample space as an S. All right. So S is what we call the sample space. All right. So, and this is all the, so for example, when we wrote all the possible outcomes for rolling a 6-sided die, this right here, well, we could say that this is S. This is the sample space for rolling a 6-sided die. Okay, so let's go through some examples. How many possible outcomes are in the sample space? All right, so first of all, we have one here. We are going to flip a coin. And when we flip a coin, there are 2 possible results. You could get heads, which I'll write as H, or you get tails, which I'll write as T. All right? And we're going to roll a 6-sided die. All right? So, and we've already said that the possible outcomes for that are 1, 2, 3, 4, 5, and 6, right? All right, but when we do these things together, all right, let's go ahead and write our sample space now, all right? So one possible thing that could happen is we get heads on the coin and 1 on the die. Another possible thing that can happen is we get heads on the coin and 2 on the die. We could get heads and 3. We could get heads, 4. We could get heads, 5. And we could get heads and a 6. All right, but we could also get tails on the coin. So we could get tails and a 1, or tails and a 2, tails, 3, tails, 4, tails, 5, tails, 6. End. Okay? And this would be all of the possible outcomes if we flip a coin and roll a die. We could get heads 1, heads 2, heads 3, and so on. All right? This question also asks, how many are there? All right, so we just listed them. How many are there? Well, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. All right, so I'm going to write the number in S equals 12. All right, that's the size of our sample space. All right, so we could also count that using our multiplication rule. There are two outcomes for flipping a coin, 6 for rolling a die. So 2 times 6 equals 12, and that gives us the number of possible outcomes. All right, next, what if we flip 2 coins? Now, again, remember, a coin can just have heads and tails, H or T, all right? So if we're going to write out our sample space for this, let's make a list. Well, my first coin, when I flip 2 coins, maybe one of the coins has a heads and the other coin has a heads. That could happen. Or maybe one of the coins has a head, the first one has a head, and the second has a tail. All right? Or maybe we could get tails and heads. Or maybe we get tails. All right? So these are the 4 different possible outcomes. All right? So the size of our sample space equals 4. Right? Okay. Good. And then let's do this last one. This one says we flip 2 coins and roll a dice. Okay. So again, let's start listing this one out. So I could get a heads on the first coin, a head on the second coin, and a 1 on the die. Or I could get heads, 2. Or I could get heads, 3. Or I'm not going to write them all out. Heads, 4, heads, 5, heads, 6. All right. Or I could get heads, tails, 1. Heads, tails, 2. And so on. Heads, tails, 3, heads, tails, 4, heads, tails, 5, heads, tails, 6. All right. Or I could get tails, heads, 1. Tails, heads, 2. And tails, heads, 3, tails, heads, 4, tails, heads, 5, blah, 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 blah. All right. Or I could get tails, 1. Or tails, 2. Or tails, 3. And then so on until I get to tails, 6. All right. All right. So that would be a list. If I wrote it all out, that would be a list of all the possible outcomes. All right. Now, how many are there? Well, in this row, there is 6. Heads, 1, heads, 2, heads, 3, blah, 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 up to heads, 6. In this row, there is 6. In this row, there is 6. And then this row is 6. And there's 4 rows. So 6 times 4 is 24. So the number of the sample space is 24. Okay? That is the size of the sample space, is another way of saying that. Okay, so that's sample spaces. All right, let's continue moving on then. All right, let's talk about theoretical probabilities. All right. The probability of an event is a number between 0 and 1 that measures the chance that an event will happen. All right. So if you ever hear someone, what is the chance that that happens? All right. Well, that they're talking about probability. It's a probability. A probability can be written as a fraction, a decimal, or you can write it as a percentage. All right. All right. So sometimes you will see percentage. All right. So sometimes you might see a fraction. They might say the probability is 1/2. Or maybe they will change it to a decimal point. They'll say, oh, the probability is 0.5. Or sometimes you will see it as a percentage, which would be 50%. All right. So these are all the same thing, and they're all talking about probability. All right. But sometimes you will see it as a fraction, a decimal, or a percentage. All right. Now, an event that is impossible. For example, if I'm rolling a die one time, what's the probability that I get an 8? Well, that cannot happen. It's impossible. A 6-sided die does not have an 8 on it. So the probability is 0. All right. An event that is impossible to occur has a probability of 0. Now, an event that is certain to occur, that means it will always happen, it has a probability of, now let's talk about that real quick. What would be a certain event? Let's say I have a coin, but one side is tails and the other side is also a tails, all right? And then I flip it. What is the probability that I will get a tails? Well, I will always get tails, all right? Always. So the probability is 1, all right? If we say the probability is 1, that means it will always happen. And in a percentage, we would say that's 100%. Sure, all right? Now, an event that is equally likely to occur or not occur, for example, if I am flipping a coin, the probability that I get a heads, and now we're talking about a normal coin with heads and tails, all right? The probability that I get heads is the same as the probability that I will get not heads, which is tails, all right? So that means it has the same probability to happen or not happen. If that's true, then we say the probability is 0.5, or sometimes we would write it as 1/2, or 50%. All right, 50%. Okay. Okay. Now let's move on to the next part. It says the outcomes for a specified event are called possible outcomes. All right, they are all the things that could possibly happen, all right, in that event. When all outcomes of an event are equally likely, the theoretical probability of the event is found as, all right, so let's go back to our die. All right, we're rolling a die. All right, when we roll the die, everything has the same probability of happening. The chance that I get a 1 is the same that I get a 2, that I get a 3, that I get 4. They are all the equally likely to happen, all right? Now, if that's true for something, then we say that the probability of an event happening is the number of ways the event can happen. Can happen. Writing with my mouse takes so much time. All right. The number of ways the event can happen divided by the number of all possible outcomes. All right. I'm sorry. It takes me forever to write. All right. Now, in a moment, we'll do some examples, so this will become a little bit more clear. Right now, you might be like, what does that mean? All right, but you'll see in a moment. All right, but just know that the theoretical probability, or just you can just say the probability of something happening is the number of ways the event can happen divided by the number of all possible outcomes. All right, and when we write a probability, if we are given a set notation, all right, we just write it as the probability of the set happening. We write probability of blah, blah, blah. All right, for example, if I was rolling a 4, I would write maybe probability of rolling 4. All right. And then write equals, and then I write the probability. Okay, so let's go ahead down here and talk about some actual probability problems. So we are rolling a die, all right? And the die has sides that are number 1 to 6. And we need to find out what is the probability of getting a 4. Okay. Well, if I'm rolling one die, how many ways can I get a 4? Well, just one way. If it lands on 4. That's the only way to get a 4. All right. So that's the number of ways the event can happen. So we put 1 on top, and then we divide by the number of all possible outcomes. Now, we already said, what is the number of all possible outcomes for a die? Well, you could have 1, 2, 3, 4, 5, and 6. So the number of possible outcomes is 6. All right. So the probability of rolling a 4 is 1 divided by 6, or 1 over 6. And you could put that into a calculator and get a decimal point, or you don't even have to put it into a calculator, 1.6667 or whatever. All right. But this is, you can just write as a fraction. That's fine. All right. Next, what is the probability that we roll an odd number? Well, again, we go back to this formula. What are the number of ways that can happen? Well, I could get a 1, I could get a 3, or I could get a 5. Those are the only odd numbers. So how many ways? That's 3 different ways. 1, 3, 5. 3 different ways. So the probability of getting an odd number is 3 divided by the number of possible outcomes, which we already said is 6. So it's 3 over 6, which can be reduced to 1 over 2. All right, so the probability is 1 over 2, or 1/2. All right. Next, what's the probability of rolling a number that's less than 3? Well, how many ways can that happen? Well, I could get a 1, and I could get a 2, and that's it. All right, 2. So there are 2 ways. All right. So the number of ways that can happen is just 2, and the number of possible outcomes is 6. All right. So it's 2 over 6, which can be reduced to 1 over 3. So that is the probability of rolling a number less than 3. All right? Pretty easy, right? And these are all not very difficult, all right? So let's look at number 6 here. We have a spinner, so it's maybe something that's like a circle, and it has a little pointer, and we flick it, and it spins around, and it lands on a number, all right? And the numbers here are divided up evenly, all right? 4, 5, 6, 1, 2, 3, 4, 5, 6. Oh, I didn't put enough in. Okay. Anyway, there's supposed to be 9 of them, all right? There's 9 places that it could land, all right? So this one's 1, 2, 3, 4, 5, 6, 7, 8, 9. And I drew it badly. Don't worry about my drawing. It's saying that all of these are equal size. So this size and this size and this size, they're all the same size, all right? They're not the same size in my bad drawing, so ignore that. But in the problem, they are all the same size, okay? So, and we're going to spin the spinner, all right? And we're going to find so because these are all the same size, we can assume that they have an equal probability of happening, all right? The chance of getting 1 is the same chance as getting 6. So we can use this formula. Remember, this works if all of the outcomes are equally likely, all right? And in this one, they are equally likely. So we can use the formula again. So it says here, find the probability that we spin a prime number. All right, what are the prime numbers? Remember, prime numbers are numbers that are only divisible by 1 and themselves. All right, so for example, 1 is a prime number because 1 is only divisible by 1. All right, 2 is a prime number because 2 is only divisible by 1 and 2. 3 is a prime number because you can only divide it by 1 and 3. 4 is not because you can divide it by 2. 5 is a prime number. 6 is not a prime number. 7 is a prime number. And then 8 is not a prime number. And 9 is not a prime number. And we just want to go from 1 to 9. So these are all the prime numbers. So how many are there? 1, 2, 3, 4, 5. So that means that there are 5 ways that we can spin a prime number. And how many different outcomes are there? Well, there's 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 different possible outcomes. So that means the probability of getting a prime number is 5/9. Okay? Next, we are going to spin, and we want to find the probability of getting an even number greater than 5. Well, which numbers here are even and greater than 5? Well, 6 is bigger than 5, and it's even, and 8 is bigger than 5, and it's even, right? Just 6 and 8 are the only two, right? All right. So how many are there? Just 2, all right? So the number of ways that this can happen is 2, and the number of total possible outcomes is 9. So the answer is 2/9 is the probability. Next, we want to spin a number that is a perfect square. All right. Well, which numbers between 1 and 9 are perfect squares? Well, 1 times 1 is 1. It's a perfect square. 4 is a perfect square because 2 times 2 is 4. And 9 is a perfect square because 3 times 3 is 9. So the number of ways that we can get a perfect square is 3. And the total possible is still 9. So then we can reduce this down to 1/3. And that is the probability that we get a perfect square. All right, next, let's do a few with decks of cards. All right, a deck of 52 cards. All right, what is the probability that we get the ace of hearts? Well, how many aces of hearts are there? How many different ways can we get an ace of hearts? Well, there's only one ace of hearts. All right. And how many different possible cards can we get? Well, there's 52 cards in the deck. So that means that the probability that we get the ace of hearts is 1 out of 52. There's only one ace of hearts. Next, what about the probability that we get a diamond? Well, how many diamonds are there in the deck? 13, right? There are 13 diamonds. And how many are there? How many total cards are there? 52. So the probability is 13 divided by 52, which, if you reduce it, is 1/4. All right? So the probability is 1/4. Okay, next. What's the probability that we get a red card? Well, how many red cards are there? Well, there's all the diamonds are red and the hearts are red. So that's 13 plus 13. So there are 26 red cards. And then there are 52 total cards. So 26/52 is the probability, which can be reduced to 1/2. All right? So the probability is 1/2. Okay. Now, real quickly, let's look back at these two. Another way of looking at this is how many suits are there in the deck? Well, there's diamonds, spades, hearts, and clubs. There are 4. And they are all equally likely to be picked. So we could just say, well, that's one suit, and there are 4 possible suits, so that's 1/4, which gives us the same answer. We could also do the same thing here. How many different colors are there? Well, there's red cards, and there are black cards. That's it. There's just 2 different colors, and they have an equal probability of happening. They are equally likely. So we are interested in just red cards, which is just one of the colors, and we divide it by the total number of colors, which is 2. So 1/2 gives us the same answer. All right. All right. Let's go to this one. A card other than 10. All right. So we don't want 10. We want any other card. Well, how many 10s are there? There are 4. So how many cards that are not 10s are there? Well, 52 minus 4 is 48. So there are 48 cards that are not 10. So we're going to have 48 ways to pick a card that's not 10, and there are 52 total possible outcomes. So it's 48 over 52, which you 24 over 26, 12 over 3. Yeah, 12 over 3. 12 over 13. Okay? And then face card. How many face cards are there in the deck? Well, there's Jack, Queen, and King. And there's a Jack, King, and Queen for each of the 4 suits, right? There's hearts, diamonds, clubs, spades, and each of them has this. So that's 4 times 3. So that's going to be 12. There are 12 face cards. So there are 12 ways to pick a face card. And there are 52 possible outcomes. So it's 12 over 52, which is 6 over 26, which is 3 over 13. 3 over 13. Boom. All right. And then finally right here we have a club that is less than a 7. All right, so we are only interested in clubs. And how many clubs are less than 7? Well, it could be the ace of clubs, the 2, the 3, the 4, the 5, and the 6 of clubs. So there are 6 of them that are less than 7. So we are interested in 6 different cards. There are 6 ways that we can get a club less than 7, and there are 52 possible outcomes. So it's 6 over 52, which is 3 over 26. And that's it. All right, we'll do these 2 problems now, and then that will be it for this class, for this lesson. What is the probability? So it says your English teacher is drawing names to see who will give the first speech. There are 26 students in the class, and 4 speeches will be given the first day. So what is the probability that you will give your speech first? Well, there's 26 names in. They're going to go first, and they're going to go. How many ways can they pick your name? Well, there's only one in there that is your name. So there's only one way to pick your name. All right. And how many total possible outcomes are? Well, how many students are there? 26. So the probability is going to be 1 over 26. All right. All right. And then the last problem that we'll do today is, what is the probability that you will give your speech the first day? Well, we already said there's going to be 4 speeches on the first day, on that day. All right. So what is the probability that you're going to have your speech given? Well, you're going to have to be, there are 4 different ways that you could be picked on the first day, right? So the probability of you going first is going to be 4 out of 26, all right? Which is 2 out of 13. All right, that is it. I will give you assignment for homework. It'll just be some simple probability problems, and I will see you for tomorrow's lesson. Bye-bye.